Hi everyone, my name is Sławek. I'm a senior software engineer at Google, and today I'm going to talk about the integration of Cloud Composer with Airflow role-based access control. So, why am I here and why this topic? I'm a tech lead in the Cloud Composer team, and Cloud Composer is a cloud service that hosts Apache Airflow software in Google Cloud Platform. So, we have quite some experience with Airflow in our team. What's at the core of my presentation is answering this question: how extensible is Airflow when it comes to its access control model? In particular, I would like to show how we can integrate it with Cloud Identity and Access Management, or Cloud IAM for short, and how we can automate Airflow access configurations. But first, a few words about Airflow role-based access control itself, or Airflow RBAC for short. Airflow RBAC is a model built into Airflow that allows managing permissions, users, and roles in Airflow UI and Airflow API. It is based on Flask App Builder, which is the underlying framework for Airflow RBAC UI. It basically allows configuring which users can see what pages and what DAGs in Airflow UI or access them through Airflow API. Note that Airflow CLI, the command line interface, does not respect these settings at the moment. You can also access the whole metadata database directly from your DAG code anyway. But in Airflow UI and API, it works. The screenshot on the left shows how permissions are grouped in a role, and the screenshot on the right shows how roles are assigned to a user. So, how does Airflow RBAC look like in Cloud Composer? When you create a Cloud Composer environment with Airflow 2, Airflow RBAC UI is enabled by default, because that's the only kind of UI available in Airflow 2. And you can see in the top right corner that you are automatically logged into Airflow UI after you pass the Google authentication. The overview of the integration setup is presented in this diagram. There are two layers. First, you reach a Google proxy, you authenticate with Google, and your permissions are checked in Cloud IAM, in the cloud project of your Cloud Composer environment, to verify that you can access the given instance at all. Once you pass this step, you don't authenticate again, more on this later, but now Airflow checks your permissions to specific Airflow views and DAGs based on the configuration stored in the Airflow metadata database, which is how it's been originally implemented in open source Airflow. How to configure access to Airflow UI and Cloud Composer? First, the user must be granted access in Cloud IAM. That's the first layer from the previous diagram. For example, Composer user role contains the necessary permission. Then, the user must be granted access to specific views and DAGs within Airflow RBAC UI. For example, an admin role is good for, admin users, as it contains permissions to all views and DAGs. But how are users registered in Airflow RBAC? When a user visits the Airflow RBAC UI instance for the first time, they are registered in Airflow RBAC automatically. Their email address and user ID are stored in a new record added to the Airflow metadata database. The default role with which users are automatically registered in Airflow RBAC in Cloud Composer is up. But this default can be modified by setting the RBAC user registration role property in the web server section in Airflow configuration override settings of the given Cloud Composer environment. You can set this property through Composer API, Composer user interface in Cloud Console, or gcloud command line interface, whichever way you use to interact with Cloud Composer itself. There is also an option for administrators to pre-register users by their email addresses manually. They are then resolved to user IDs at user login time. This is useful for assigning roles to users before they log in, because a user record must be created in an Airflow metadata database before roles are assigned to the user. Now, let's dive into some details of how we adjusted Airflow to make this seamless integration possible. Airflow is already integrated with Google Authentication, but the problem we faced was that users would be greeted with two authentication requests, one from Google Proxy and one from Airflow UI. That's no good, but thankfully we managed to eliminate the need of the second sign-in by making use of user identity passed from the proxy in a signed header. The header contains a unique stable identifier of the user and their email address. They can be used to register or log in the user into Airflow UI. And that's exactly what we did by implementing a custom login handler in the Airflow web server. The handler decodes user ID and email address from the header, looks up the user in Airflow RBAC tables in the Airflow database, and if the user has been pre-registered with an email address, updates the records with the user ID, or if the user doesn't exist, it creates the new record in the database for this user. And finally, the handler logs in the user. Looking into the code, the implementation is actually pretty clean here, as Airflow web server is ready for such a customization. All we did was providing custom auth view and Airflow Security Manager implementations, which include the login handler logic that I just described. And then we set them in the common webserverconfig.py configuration file. And voila! A user is registered and logged in automatically with no need for the redundant second sign-in step. But when it comes to interacting with Airflow Access Control, we didn't stop there, and to further improve the experience of configuring access control in Airflow, we proposed a feature called per-folder roles registration. What problem does it solve, and what does it actually do? DAG-level permissions are an important part of Airflow RBAC. They enable limiting which users see which DAGs in Airflow UI. Adding per DAG permissions to roles can be done either by editing roles in Airflow UI or by specifying roles and permissions through the access control property in the DAG code. This is shown in the screenshots. And this works, but what if you have many DAGs and many roles to which you want to add the per DAG permissions? In that case, maintaining a consistent configuration can be cumbersome and error-prone if it depends on manual configuration of every single DAG. This is a problem that we've identified and wanted to solve it through automation. But how can we automate assigning DAGs to roles? This is where we came up with the idea of per-folder roles registration. In this approach, DAGs are naturally grouped by subfolders in which the DAGs and their files are defined and where they are located in the file system, or in subfolders in Cloud Storage Bucket in case of Cloud Composer, because that's where you put your DAG files when you deploy them in Composer. Then we can use the subfolder names as role names, create the roles in Airflow RBAC, and populate them with edit and read permissions to the DAGs which files are located in this subfolder, all automatically. This is pretty clean, and it automates the DAG to role assignment. How did we implement it? We used another Airflow customization mechanism called cluster policy, which enables you to inject code to execute in the context of parsed DAGs or tasks. Here we operate on DAGs, so we define the DAG policy in the standard Airflow local settings.py file. This policy has just two steps. First, it extracts the role name from the DAG file path. I didn't include the implementation of the role from file path function in this slide, but you can imagine it's pretty simple. Then it merges the new per folder role and permissions to this DAG with the additional DAG access control settings specified by the user in code, if any, because they are completely optional now, thanks to this automation. This way, both become effective, and that's it. In the recent versions of Airflow 2, settings from the modified access control property are automatically synced to our Airflow RBAC tables. Admittedly, we also needed to add a couple of small patches in other places of our Airflow codebase to improve handling certain scenarios, like when a DAG is deleted. But hey, with open source code, that's easy too. We added the per folder roles registration feature to Airflow instances available in Cloud Composer. You can simply enable another Airflow configuration override in Cloud Composer environment settings. It's called RBAC Autoregister Per Folder Roles in the web server section, and you can set it to true either through Composer API, Composer user interface, or gcloud command line interface, again, whichever way you prefer. And then you're good to go. The feature is enabled for you, and you just put your DAGs, your DAG files into subfolders, and the structure is automatically mapped to roles with per DAG permissions assigned to those roles. This way you can, for example, streamline the scenario of multiple groups of people in your team working on different DAGs, so that each of them can only see the DAGs relevant to them, effectively decluttering the view in Airflow UI. To summarize, I believe we demonstrated that Airflow is extensible, also in the more advanced area of role-based access control. We integrated it with cloud identity and access management in some form, and further extended Airflow access control with per-folder roles registration mechanism. And that was without deferring to many hacky patches, but rather using the available configuration and customization mechanisms. If you want to learn more about Airflow UI access control and its integration with Cloud Composer, please check out the Airflow documentation and Composer documentation as well. Thank you for your attention. It's been a pleasure to speak at this event, and I hope you learned something today. Thank you.